A few weeks ago I built this oil can from plans I downloaded from the Hobby Machinist forum site. It worked out pretty well, so I thought, for the next challenge, let's see if I can build something smaller. So instead of a 50mm can, I'm using 40mm solid bar. This doesn't seem like a lot smaller, but it really is very much smaller. In this enlightened country we use the metric system, and so I set about trying to modify the original plans to my smaller design and using metric measurements. This proved to be a bigger challenge than I thought and caused me a number of problems, but I finally succeeded. Anyway, what you can see me doing here is milling down a piece of flat bar that's going to be the contents of the oil can, and this makes the two outside edges round so that they'll fit inside the round part of the oil can body. Before I wasted any more time on this project, I thought I'd build the piston. I found in the last project that this was the most difficult thing to get right, to get the tolerances correct. So I thought, if I can get this correct, I can probably make the project work. As you can see, the piston is quite small, and the version you're seeing here ended up being in the bin. It took me a number of tries to get that piston correct. I'm using a piece of scrap here with the designed hole, and you can see that I haven't got it correct yet because that piston is just too hard to move in. So keep trying. Yeah, well, that sort of looks okay, but in the end I found that there was too much friction there. Anyway, I think it's going to work, so I've got a piece of this solid 40mm round bar. It's aluminium, and I'm going to hollow out the centre. I want to end up with just 2mm thick sides. I'm going to end up having to use a boring bar, but I'm starting a big drill, which is complaining, but it's doing the job. Now to finish it off with the boring bar. Now of course I'm not going right through, so this will make this nice and oil tight. I'm loving my DRO. It makes getting the final dimensions so much easier. Okay, I still need to take 5.75 mils off. And just like magic, the body's finished. I've got a bit of scrap with a hole in it, which doesn't matter. I'm going to use this as the base. Again, using the DRO to get the final measurement, I've got a nice tight fit. It's not going to push in, but it's going to tap in. That'll be perfect. And now for the top cap. I don't want the top cap to be that fat, so I'm just parting off the excess. Here's the body, base and top almost completed. That'll tap in, and the top just goes on like this, and I'll use an M6 bolt to hold it down. Now it's time for the various fittings. I'm just using M8 bolts for this. There'll be a fitting in the bottom for the bottom intake tube, and then in the outlet tube, and then the bolt that holds the piston in. So all these have to be drilled either singly or drilled and then turned around and drilled a little bit bigger. So in this case, this is where the bottom ball bearing will sit. Right, that's the intake done. You can see that at one end is the intake tube for the oil to come into the inside body, and then a little 3/16 ball bearing will sit in there in the larger hole. Will allow the oil to come in because the ball bearing will be pushed out of the way, but as you squeeze the plunger, the ball bearing will sit down and stop the oil going back out the intake. Same sort of process for the piston retainer and the outlet, and now it's time to just make the little nozzle that goes on the end of the outlet tube. I've drilled a 1.5mm hole right through that little nozzle. Now I just need to turn it round and drill a larger hole for the brass tube itself. I've done all the bits that I need to do on the lathe. Now I need to work on the complicated bit that goes inside. This is the smart bit that makes the ore can work. I'm not going to try to explain the complexity of the mechanism. If you're really interested, I've left a link to the plan downloads, and you can go and register yourself on the forum, download the plans, and have a look at how the mechanism actually works. It's simple, but yet complicated and brilliant. And as I mentioned, I had to remake the piston a couple of times to get it right, because I'm only a backyard bodger, not a proper machinist. But I got it in the end, and I guess that's all that really matters. And I learned a thing or two along the way. It's time to assemble. Little ball bearing goes in that bottom bolt for the intake. The spring goes in the piston tube. The other ball bearing pops down from the top. Bit of a tap just to make sure it seats properly. Little spring goes in there as well. Then a bolt goes in the top to hold that spring and ball bearing in. That top ball bearing moves up and down depending on whether you're pumping or releasing. This ball bearing seats when you're releasing the piston. That causes a vacuum and sucks the oil in from the bottom. The subsequent vacuum allows that bottom ball bearing to move and allow the oil to come in to the body. Now, before I go any further, let's see whether this thing actually works. Well, surprisingly it does. The base will be a tap-on fit, but I'm just using a bit of thread lock just to be sure. Okay, the job's almost complete. And now for a final test. It doesn't dispense a huge amount of oil, but I think it's fine. I think we'll call that a success. And so, we've got the small oil can and the large oil can.